Hello children, today we are going to see first topic in mole concept or what we call stoichiometry. There are 7 different types of sum. So we start from easiest to the hardest. So if you see any book, especially the last book, you have 7 type of question. So if you see page 99, 100, 101, in old book and new book, you will see 3 pages where previous year questions are given under A, B, C, D, E. And I think we start percentage composition. If you see the book, you will see percentage composition is in the part E. See page number 100. Okay, so percentage composition is E, then we will go to F. So if you see, it is E. Okay, so we start from easiest to hardest. Okay, first we'll see percentage composition, then other video we will see empirical and molecular formula. Then we may move on to chemical equation G, which is most important. Every year you have 1 or 2 questions on the G subsection, where the questions are given, previous year questions are given. So there are 7 categories. So G is most important. Then we will see Avogadro's law and Gay-Lussac's law. So we will have a number of videos. This is part 1 if you see, children. So here we do percentage composition, where we see in a molecule like this. This is 1996 question, the very first question under E in the last book you will see. So we have to find the percentage of oxygen in magnesium nitrate crystals. So it is magnesium nitrate heptahydrate 6 water of crystallization. So before we start, it is part of mathematics only, where we have application of percentage. So percentage, if you see from class 7 onward, is part by whole into 100%. So here we have percentage composition. It is percentage by weight of each element. So if a compound is there, if you find percentage of each element, so there are 4 elements over here: oxygen, nitrogen, magnesium and hydrogen. So if we add all the percent, we will get 100. So it is percentage by weight. So what is percentage composition? Weight of an element. So we will see with example, like here, what is the weight of oxygen in one molecule of a compound. So one molecule, so here we will see 3 2s are 6 oxygen and 6 oxygen, 12 oxygen. So what is the weight of 12 oxygen atom in gram molecular weight of magnesium nitrate heptahydrate? We will see. So since it is percent, so this upon this into 100%. Okay, so we will solve and see. So first we have to find, children, the molecular weight. In this thing first, class 9 also you have seen, we find molecular weight. So here first we will find molecular weight of magnesium nitrate, and then so here you will see in ICSE generally 2 things are always given in these questions. Number 1 is you will have the formula, but I see in some question, if it is a tricky question, you will see formula you don't get directly, especially in 11 and 12. So in 10% of the question, or sometimes teacher set a hard paper, they don't give you formula, you have to find the formula or write from your own. So formula is generally given in ICSE and the atomic weight. But some common atomic weights, children, you can remember, like we have oxygen 16, nitrogen 14, because sometimes some values may be missing in question paper, sometimes some teacher don't give the atomic weight. So please remember this, some common atomic weights of element. Especially the very common one I have written. If it is something else like platinum and all, it will be given. Oxygen is 16, nitrogen is 14, hydrogen is 1, remember, children. So oxygen, if you see, the atomic number is 826 electronic configuration. So here we have double of that. Generally atomic weight is double of atomic number, or 1 or 2 more, like see sodium. Atomic number is 11, 281. 281 is electronic configuration, 11 proton, but it has 12 neutrons. So it is 23. So anyway, how it comes, since you have done periodic table in class 9 and this class also you may have done, you will do. So this you can remember, chlorine has a fractional atomic weight Class 9 we had the answer 35.5, fluorine 19, aluminum 27, magnesium 24. So these are very common children. Carbon, oxygen, nitrogen, and hydrogen. Carbon is 12, nitrogen is 14, hydrogen is 1, oxygen is 16. Calcium 40, you may learn if you wish. Sulfur 32, copper is double of that. Half of sulfur is oxygen we see. So try to remember some common atomic weight. So with this idea, what we will do first, children, we will find the molecular weight of this, and then we will see what is the total weight of oxygen, okay, weight of element oxygen in one molecule of compound, and then we will see what percentage of oxygen is there. So kindly pause the video and copy. Then we will first find the molecular weight of magnesium nitrate heptahydrate. Now we find the molecular weight of magnesium nitrate crystal. So if you see, children, magnesium nitrate 6s2. So before I go into detail of molecular weight, one small thing I'd like to focus is molecular weight of water. So water is made up of 2 hydrogen atoms and 1 oxygen atom. Okay, O stands for, remember, oxygen. Okay, so that's why I have put it in a bracket. Hydrogen is 1 and oxygen is 16. So gram molecular weight of oxygen is 18. Okay, molecular weight expressed in gram. So water is 18, children. 2H plus 1 oxygen. Hydrogen is 1, 2 1s are 2, and oxygen is 16. So if we find this, we see magnesium, there is 1, there is 2 nitrogen atom, children, plus 6 oxygen atom. Plus here, this dot, children, does not mean multiplication over here. It means, if you have seen from class 9, water of crystallization, loose combination. Means which can be lost partially or wholly. So though it is dot, so in maths what we see, we call it multiplication. But it is addition over here, 6 into H2O. So how we get, children? See, magnesium is 24. So generally it is given, children. Nitrogen is 14, oxygen is 16, and each water molecule is 18. So once you remember about water, you can directly apply. Otherwise, you have to do 6 2s are 12 hydrogen and 6 more oxygen. So if you add 24 plus 28 plus 96 plus 108. Okay. So 16 is 108, 66 are 96. So if you add all of them, children, we will get the molecular weight of magnesium nitrate heptahydrate. So let us add 16, 6, 24 and 22 and 4, 26, 2, 11, 5, 1, 256. Okay, so molecular weight of magnesium nitrate heptahydrate is 256. Now we have to see what is oxygen over here. So see, very nicely I use a green pen. How much oxygen is there? So if you see over here, children, there are 6 oxygen here and 6 oxygen there. So if you see total number of oxygen atom over here, see, we have to take water of crystallization also. So weight of oxygen atom, or we can say total weight of, okay, you can add total weight of oxygen atom is 12 into O. So 12 oxygen atoms are there, once more 6 here and 6 here. So 12 into 16 is 192. So out of 256, the weight of oxygen, 12 oxygen atom is 192. So finally you copy, and then last step we will get what is the percentage of oxygen. Okay, now, So what we do, children, what is percentage of, same formula I use, children, percentage of oxygen is weight of element in one molecule of compound. Weight of oxygen in one molecule of magnesium nitrate heptahydrate is 192. What is gram molecular weight of the compound? 256 into 100%. So if you solve this, okay, let us cancel and see how much you get. So you cancel with 2, you get 2 9s are 18, 6, 2 1s are 2, 2, 8. Again we can cancel 64, we get 48, then we get 32, 24, 16, 12, 8, 6, 3, 4. So we get, children, ultimately it is 3 by 4 into 100%. So if you cancel, it will go by 25. So answer is 75%. So in later on question, maybe I will not show you the detailed calculation as to how we add, since this was first sum, and how we find percentage. I'll show you over here, but I hope in class 10 you know how to cancel. So we cancel and we get that percentage of oxygen in magnesium nitrate is 75%. So after this I'll take 2012 question. This was year 1996. So very similar question you see, but in that question I think we have to find the percentage of magnesium in same compound. Here it was oxygen. So, and if you add all the elements percent, children, total you will see, you will get 100%. So kindly pause the video and copy, then we will go to other sums. So if you have seen, I have done question of 1996 where we were doing percentage of oxygen. So in 2012 exactly we have same question, but here we have to find the percentage of magnesium. So if you see that we have found the molecular weight of magnesium nitrate to be 256, weight of magnesium, atomic weight of magnesium is 24. So percentage of magnesium is atomic weight of magnesium by molecular weight of the compound magnesium nitrate hexahydrate. So I think if you solve this, you get roughly 9.375. So we can round it off to 9.38. So this is year 2012. So this was very similar to the first question which we did. So magnesium, there we found the percentage of oxygen, here we do magnesium. Very similar question came in 2017. So here we have to find percentage of water of crystallization. So one thing you remember, dot means loose combination, so we don't multiply, we add here. So very interesting thing, you see copper is 64, so we are trying to find the molecular weight of copper sulfate. So we are going to find molecular weight. So see, molecular weight, it's quite simple. We add all the atomic weight which is given. Okay. So molecular weight, so copper is 64, sulfur is half of that, and oxygen is half of sulfur. So very interesting, copper is 64, sulfur. So 1 copper atom, 1 sulfur atom, 4 oxygen atom. I told you, remember, oxygen is 16 and hydrogen. So here I told you, children, water is 18 gram. Gram molecular weight of water is 18 gram. So we don't do 2 plus 16 and we add here. Dot means loose combination. When you heat, it can be lost partially or wholly. So if you add, children, 64 plus 32 plus 64 plus 90, let us add and see what is the molecular weight. 110. So it's 250 gram. Okay. Now, gram molecular weight is 250 gram. What is percentage of water of crystallization? So percentage of water is C90. Water is 95 into 18 upon water of crystallization, you can write. So 90 by 250 into 100%. So in this particular molecule, copper sulfate pentahydrate, how much water, percentage of water molecule is there? We take 90 upon the molecular mass of the copper sulfate pentahydrate into 100%. So we cancel 25 4s are, so 9 4s are 36%, means out of 100, if this is water of crystallization, is 36%. So kindly pause the video and copy, then we move on to the next question. Next we move on to ICSE 22. See, in 2020, if you see previous year question, we had only 5 paper, then COVID came. So after 5 paper, ICSE was stopped, and then 21 there was no ICSE. Okay. 22 we had 2 semester, children. Okay. In December we had semester 1, I think, where this MCQ came. This topic was, I think, in semester 1, and then this was in December 21, and in March 22 we had the semester 2, but from 23 onward we have only 1 exam. So this was 1 MCQ question, 1 mark question. Percentage of hydrogen in NaOH. So sometime in MCQ question, children, you have the relative molecular mass given. If it is gram molecular mass, means it will be written in gram. So relative molecular mass, generally unit is not there. Gram molecular mass, we put gram. Okay, atomic weight of hydrogen is given. We have to find percentage of hydrogen. So 4 choices are given. So suppose relative molecular mass is not given, then what will be given? This is given, we don't need here. Molecular weight of NaOH. Just I am telling, if it is not a 1 mark question. So what will be given other than, here it is given 40, so I'll show you how it is 40. If this is not given, it will be given atomic weight of Na is 23, H is, I told you, 1, and O is 16. So this will be given in place of this. So Na is 23, O is 16, and hydrogen is 1. So you get 40 as relative molecular mass. Okay, relative molecular mass means we compare with 1/12 of carbon. Previously it was hydrogen atom. So just remember atomic weight and we add and we get molecular weight. So relative molecular mass is without gram. When it is expressed in gram, we call it gram molecular weight. Okay, so this is 40. So we have to find percentage of hydrogen. So if you children, it is 1 only. 1 upon 40 into 100%. Hydrogen is very light, remember. In any compound, no, the percentage of hydrogen is least because it is lightest. Its atomic weight is 1. So 1 over 40 into 100%. So if you cancel 10 by 4%, is 2.5%. So first option is right. You would have written that particular question number. Suppose here it is 1, A, 2.5. Since percentage is mentioned here, it is not mentioned over here. So this is the correct option. Okay, so sometime in MCQ you will see you don't have to find relative molecular mass. Okay, molecular weight, it is given and we directly apply that. So kindly pause the video and copy, then we move on to the next sum. Next we move on to year 1997. Then another very interesting sum we'll take later on. So mass of nitrogen in 1000 kg of urea. See, this is the formula of urea, one of the very important nitrogenous fertilizers. So we write something like this. Okay. Formula of so urea is CONH2 whole twice. So this is how we write the real molecule. So if you have seen in class 7, we have three type of fertilizer, NPK. So soil is interested in nitrogen. See, there are hydrogen, carbon, oxygen. So soil is only interested in nitrogen part of this compound, like calcium nitrate. Then NPK, there is phosphorus, phosphatic fertilizer, potassium based fertilizer. So there are three basic requirements for the soil when you use artificial fertilizer. We call it NPK, nitrogenous, phosphatic and potassium based. Okay, so here urea, what we see, soil is only interested in nitrogen because that will help in the growth of the plant. So first we find the molecular weight of urea. So if you say nitrogen, there are 2 into 14, there are hydrogen 4, and there is 1 carbon and 1 oxygen. Okay, so oxygen is 16 and here hydrogen is 1. So we get 28 plus 4 plus 28 here. So we get 60. Okay. So this together is 28. So we see what is nitrogen in that, C28. So if you write in grams, so we can write in kg also. In 60 gram of urea, nitrogen is 28 gram. If you take in gram molecular weight, this is RMM without grams, so relative molecular mass. So gram molecular weight, 60 gram of urea, we have 28 gram of nitrogen. There are 2 nitrogen if you see. So you can write in the same way in 60 kg, because if you multiply by 1000 both the side, so 60 kg of urea, nitrogen is 28 kg. So if you take 1 kg of urea, nitrogen will definitely be less. Unitary method 28 by 60, because in 60 kg it is 28, so 1 kg it will be less. So we want in 1000 kg. So it will be 28 by 60 into 1000. So we cancel. So we get 1400 by 3 kg. Okay, so if you convert it to decimal children, you will get, so you will get 466.666 like that. Okay, it will go on. So if you round off, you will get 466 or nearest kg. I think question says nearest kg, you will get 467 kg. I think answer says to the nearest kg. Once more, urea, we find the molecular weight. Okay, NH2, remember, this is the structural formula. Molecular weight of urea, we got 60. Nitrogen 2 into 14, 28 out of 60. Hydrogen is 4 and carbon is 12 and oxygen is 16. So we see 28 gram of nitrogen is there in 60 gram of urea. We convert it to kg. 1 kg is this much of urea will have this much nitrogen. and 1000 kg will have this. So another way we could have done, children, is by percentage. So next we can do, let this be called, we call it method 1. So method 2 will be, we use percentage. Percentage composition, see, I use that idea. Percentage of nitrogen is 28 out of 60. So this, if you find, children, this will cancel. You will get 140 by 3%. This will be 46.66, like this will go. So we get 46.7%. So 100 kg of, percentage means of urea, 100 kg will have 100 kg of urea will have 46.7 kg of nitrogen. So 1 kg will have this, or directly you can come to 1000 kg 10 times, children. Directly you can multiply by 10. 100 kg, 1000 kg is 10 times more. Otherwise, unitary method you are doing, you can use that. So 1000 kg will have, okay, 467 kg of nitrogen. Once more, percentage you get means out of 100. So 100 it is this, 1000 will be 10 times more. So directly you can come from first to third step. 1000 will be 10 times more, or you can find like unitary method. See, many of this question can be solved by ratio method also. So if you want to be good in this, you have to be good in maths. Okay, children, so kindly pause the video and copy. Then we move on to one very interesting sum. Now we go to the very last question, but very important question, where we see application of chemistry in geography. There is a subject called agricultural geography, where we study about the requirement of various crops. So here you see there are some mathematics also. Let us see the beauty of this sum. So there is a crop of wheat. So this is very close to reality. Punjab, Haryana, maybe in Bengal we have wheat we grow. 20 kg of nitrogen, pure nitrogen is required as a fertilizer, as a iron for per hectare of the field. What do you mean by hectare, children? So first concept, what is hectare? It is 100 square of 100 meter by 100 meter. I hope you have understood how big. If you have a school field anywhere, 100 meter race, I think all of you see during sports time. So 100 meter by 100 meter if we have. The length of the square is 100 meter and the breadth, like a room we have. Okay, this is my square room. 10 feet by 10 feet. So same way 100 meter by 100 meter. This is, children, called 1 hectare. So suppose a farmer has a 10 hectare field. So 1 hectare field, okay, requires 20 kg. Who is saying? Question is saying. So 10 hectare, 10 times bigger. 10 hectare requires 10 times more. So how much I need? I need 200 kg of nitrogen. Okay. So how much calcium nitrate? So previous sum, if you see, children, I had solved. We had urea, NH2, CO, NH2. So here I told you soil and it is interested only in the nitrogen part. This is nitrogenous fertilizer. Another nitrogenous fertilizer is calcium nitrate. So where the soil is interested in nitrogen, you can see wheat requires this much nitrogen. Wheat is not much interested in calcium and oxygen. So we have to see, if we have 20 hectare field a farmer has, where the requirement of each hectare is 20 kg of nitrogen, how much calcium nitrate. Last question was children urea. Same question what I do when I give question, I make it urea. How much urea is required? So when I set my paper, I do little twist and turn so that you develop your analytical skill, because now next year onward, you are the first batch, you will see 2024 onward that ICSE is introducing analytical question. So you have to think beyond book and out of the box, what we call. So here we go, children. So first, in all these questions, we find molecular weight. So what is molecular weight of calcium nitrate? So it's quite easy, children. Calcium is 40, there are 2 nitrogen and there are 6 oxygen. So here we go, 40 plus 28 plus 96. Okay, so we add and see, we get 164 for 1579, 164. Now see the last part of it. Very interesting. 164 kg gives 28 kg of nitrogen. If you take 164 kg of calcium nitrate, 28 kg is what is important. So 28 kg, I just reverse it, of nitrogen is given by 164 kg of calcium nitrate. So if 1 kg of nitrogen you require, you need more, see more than 1. 28, we need 164. So 1 kg, if you want nitrogen, we require 164 by 28 kg of fertilizer calcium nitrate. So if you require, children, how much? 200 kg. I told you 1 hectare requires 100 meter by 100 meter field, requires 20 kg, so that farmer has put wheat in 10 hectares of soil. So we need 200 kg. So 200 kg of nitrogen will be given by 164 upon 28. So this is basic unitary method, children. You have to see class 6, 7 maths where you have my video also. Okay, unitary method you have to see. Okay. So 164 by 28 into 200 kg. So if you solve this, you will get roughly 1.77, 1.4 or something, means 1171 kg of calcium nitrate if you take, then 1100, 5.5 times more, around 6 times more you have to take calcium nitrate so that you get 200 kg of nitrogen. So if a farmer has to buy 100 kg bag of calcium nitrate, he has to roughly buy 12 bags, 12 into 100, 1200. So 12 bags of 100 kg of calcium nitrate he buys, then he will get around 200 kg of nitrogen, which will be enough for crop of wheat, which he is sowing in 10 hectare of land. So see how we have chemistry over here, okay, how we have maths over here, and how we have agriculture over here. Okay, so very interesting, and this was the hardest question, children. So maybe one more video I'll make later on. So basic idea I have given you in this half-an-hour video. So you please do other sums. So what I have not done, if needed, I'll solve in my part 2 of video on percentage composition. So my coming videos will be on other 6 topics of your stoichiometry, that is what we call mole concepts or numerical in chemistry. Thank you, children, for watching this video lesson.